RuneScape is a classic MMORPG that encompasses many different activities. Such activities can include a diverse range of skills, quests, minigames, as well as combat. This could mean you're spending time training a skill such as agility, it could mean you're spending hours killing demons, or it could even mean you're spending hours clicking on rocks in order to mine iron. So the question becomes, how do we automate the process of all this tedious grinding that we have to spend hours upon hours doing? The answer is that we create a bot. RuneMate is a platform that hosts hundreds of published bot scripts for RuneScape. They include automation utilities for most activities you can think of. They have an active community which hosts support forums, as well as a Discord for developers. They also have an API as well as an executable client, which is used to reverse engineer some of the in-game commands and properties. There's so many different things you can do in RuneScape, and many of them are pretty boring. So I tasked myself with figuring out some problems that required automation within the RuneMate community. I also took it upon myself to survey the players of RuneScape to figure out which skills were either the most grindy or just painful to train. One of the most common responses I received was agility, which isn't surprising because agility is a skill where you complete obstacle courses in a loop, and it often takes hours to progress your skill level. So I decided that building an AI that completes an obstacle course would not only be useful, but also pretty simple. I mapped out the area and decided I'd be making a bot for the Gnome Village obstacle course. It's an entry-level agility course, which means players of all levels can make use of it. The agility course is pretty simple and consists of a few different areas. I divided each of these areas into small sections of the map labeled as zones. There's 7 distinct obstacles in the Gnome Agility course, and each will guarantee success on each attempt. This means you won't have to worry about falling off or taking damage during the course. Each of the obstacles is assigned a corresponding zone, which is used as an input state to whatever decision your character needs to make. The first steps were just to really visualize the game area, but once that was all understood, it was time to start drafting the logic. The first thing I had to do before I wrote any code was to determine the approach. A very common and naive way to think about programming a bot script would be thinking in terms of a loop. In many cases, this approach is simple and it works depending on the problem you're trying to automate. However, this approach is faulty and it can cause bugs because it doesn't revalidate states that are subject to change. For this reason, the logic of the AI was organized into a decision tree, which is just a binary tree which is used to validate the proper action at any given input state. For the purposes of the Gnome Agility course, the logic was pretty simple because each zone corresponded to a single obstacle. Once I had drafted the visual diagram of the tree, I used a tool to create a Java skeleton of my decision tree. All I had to do was start with the parent node and assign the corresponding children nodes based on either success or failure. If a node responded with success, you traverse down the right branch, whereas if a node fails, you traverse down the left branch. Once this tool had the entire logic, all I had to do was export it in order to create a Java skeleton with all the classes I needed. The next steps involved actually writing the code, which is where we get into the RuneMate API. This is where I had to interact with the reverse engineering tools in order to query the gamed client's elements. The RuneMate client allowed me to capture the map coordinates for all 7 zones. I also was able to capture the numeric ID, which is used to identify each obstacle that needs to get clicked on. All of this information was recorded so that I could use it while implementing each Java class. Each of the classes represent a node in the tree. They were organized into either branch nodes or leaf nodes. Branch nodes are used to validate whether a condition is true, while leaf nodes are considered terminal states where actions are executed. Implementing the branch nodes were straightforward, while the leaf states involved more null checking. I had to query the client state to find the obstacle, and if it wasn't able to find the obstacle, it would turn the camera and reattempt the query. After some brief debugging, I was able to complete the final product. I supervised the bot for a few hours to make sure everything ran okay, and I haven't noticed any significant issues. Being able to accomplish a practical utility was pretty satisfying, and I was able to learn a lot during this project. I'm also glad I worked out a way to no longer waste as many hours of my life on RuneScape. I hope you've enjoyed this production, and thank you for watching.